Hello there, good people. Welcome to Physics 11 out of 11. Here's what we're looking at for this session. This has to do with that's a refresher review of algebra. Now, let's suppose you're given that expression there to solve. All the numbers are on the right-hand side. You just got to do them in the right order. And as a reminder, the order is on the left-hand side, where B stands for brackets, meaning you do whatever is inside the brackets first. E, that stands for the exponents. So you apply to the exponent to the number or expression that it's on. Okay? Not any extras. I look at this. The exponent of 2, the little guy, is on the 3 only. Okay, so don't go including that other big 2 in front. That'd be a disaster. But we'll do it step by step so you can see. Next, D, dividing. Or division perhaps. M, multiplying. Multiplication. Now with these, they actually count as the same. The important thing to do is to do them left to right. You do them in the order that you see them. You don't do dividing first and then multiplying. They both count as the same. Left to right for these guys. Then you have addition and then subtraction. And these two, they also count as kind of the same. Right? So you go left to right in order to make these happen. So let's take a look at this this expression here. And let's work it out. See what we get. So it's already written down for you. You don't have to do that again, but I'm going to do it there so I can see it. Right? So, any brackets? Nope. Any exponents? Yep. So I do those exponents first. So I get 2 times 9 plus 1 like that. Then I go in order, starting on the left over to the right. Any multiplying? Yep. 2 times 9. That's it for this one. 2 times 9, 18. Then I do any adding or subtracting. Again, going left to right. Well, clearly it's just that that's left. So bring the x down. Don't leave it way up at the top like that. X is equal to 19 for this particular question. Now then, what we can do is, as it shows, we can swap the x into part of the equation, and then you have to solve for that x. Well, what happens then? Okay, so I guess we'll take a look at these blanks first to help you out there. So now, for this concept, it says what we need to do is, well, we need to rearrange the equation to solve for x. That's really what we're doing. In fact, you can just erase everything. It'd be wrong, but erase everything. Okay, it doesn't work. So what we have to do is we have to rearrange in a special way. We have to rearrange so that we undo. That's the next blank. In other words, we want to undo the operations so we can get an x on one side of the equation by itself. In other words, what we're doing, you'll hear this expression, is isolate x, or even solve for x. That counts as well. Solve for x means do good algebra to get x by itself on on one side of the equation. Well, how do we do that? I guess notice before this goes off the screen, we have bed mass for working out what the expression's worth, or that is when x is by itself there, right? But if we're going to do the rearranging, what we do is we do bed mass backwards. Samdeb, if you like. Okay. Now, so for number one there, Samdeb, just to highlight, that's bed mass backwards. But for number two, the second thing, we can do whatever we want to one side of the equation as long as we do it to the other side. Okay, as long as we do the same thing to the other side. Because an important concept for this is that you have a seesaw that's level and balanced. So if you make this side heavy, that side has to be heavy so that it stays balanced. If you do one side only, then the seesaw is going to go like that. Right? Or if you do this side, make this side heavy only, it's going to go like that. Right? This side's going to go down. Basic physics. Right? So what you do to one side, you do to the other. If you add 10 to this side, you add 10 to that side. If you take 10 away from this side, you take 10 away. If you double the mass on this side, you double the mass on that side. Right? If you divide this by 3, you divide this by 3. Okay? On either side. By the way, of the equal sign, other side of what? Equal sign is where the center of the seesaw is. So let's try this bed mass backwards. Let's try this Samdeb on this expression here. Well, what you do to one side, you do to the other, and there's a special order. So I guess we should write it down. What do you want to do, bed mass backwards or Samdeb? I'm going to do bed mass and just start at the bottom and go up. So you have this already. 3 is equal to 2x squared plus 1. Rather, 2 times x squared plus 1. Okay, and so we got to work at the bottom and go to the top. So any subtracting or adding first. Yeah, well, this thing's added on. So you undo it. The undoing of a plus is a minus. The undoing of a plus is a minus. And what you do to one side of the equals, you do to the other. So then working vertically. Look at, beautiful lined up. Beautiful. 3 minus 1, 2. Is equal now to 2 x squared. And this is gone, which is the intention. 1 minus 1 is 0. So I could put a plus 0 there, but it would just mean an extra step of writing. Okay, so if you're all right, we can go, just leave this blank as a 0. 1 minus 1 is 0. It's there but invisible. Now what do we do? Any dividing or multiplying? Well, this 2 is multiplied by that x squared. And there's no brackets, but it actually is a separate thing. So what you do is you now divide both sides. Well, first of all, you divide this side by 2 so that it divides out and is gone, just like we did with conversions. But you divide 2 on that side, you divide 2 on this side. And it so happens they're the same, so they divide out And they're gone as well. Gone meaning it equals 1. 2 divided by 2, 1. 2 divided by 2, officially it's 1 just to show you, but you can leave it off as we usually do. So you get this. And we're almost there. Next is to take care of the exponents. Well, there's an exponent there. And now, to undo something that's squared, what you do is you take the square root of it. And importantly, there's another piece. What happens is when you do this, you end up getting a plus and minus showing up as part of the answer. So square rooting x squared, you get x. And then you got to square root this side. Well, what's the square root of 1? Right, 1. Now, because of this side, because we're square rooting x squared, we get a plus and minus 1 showing up. Okay, that's the deal. Any brackets or anything left? No. Okay, so this is it. We're done with that. What we did is BEDMAS backwards to solve for a value of x that's inside of an equation. How? Just by undoing, using the opposite operations, by undoing what is there. So let's take a look and see what's next. I have an idea. As we proceed, what happens is we have to deal with letters as well as numbers. Now, notice what this thing says. This says solve for VI, which is inside of that equation up there. So there's actually two different ways to do this. One is to put the numbers in first, then work it out. The other is to actually work with the letters only and put the numbers at the end. For you, both are a good workout. So we'll do version 1 to start with. And we'll see where we are and what we got. Well, we have VAV is equal to VF plus VI all over 2. And by the way, these AV, FI, those are subscripts. Sub for under. Subterranean, under. And just like in chemistry class, you see H2 and O2 and all that stuff. That's it. So this VF is one whole symbol. VI, one whole symbol. Divide by 2. So I'm going to do the numbers first. The numbers. And that's going to put, as you can see, V average is 4. Nice lined up. Beautiful. 4. VF is, 2.3. Okay. And what are we doing? Solving for VI. This whole thing, because the formula says average of anything is divided by 2. That's where that comes from. Just the average. 2 things, so divide by 2. So now you got to work this out. Well, one thing you need to know, perhaps remember, is that whenever you have a fraction, the top is in an invisible set of brackets and the bottom is in an invisible set of brackets. Okay, but importantly, in this question, the top is, right? 2 is just 2. So that means when we're looking at our BEDMAS, should have put it here, but I'm going to put it over here. Remember, we're going to do this backwards because we're solving inside of the equation there, right? We do the brackets at the end. So it's a 2.3 plus, which might suggest we deal with the adding in the beginning. But But no, because it's in brackets, we do it at the end. Because remember, with solving, we're going backwards. Kind of. So, no, we are. So, any subtraction or adding? No. This doesn't count, remember? It's in the brackets. So, any multiplying or dividing next? Yes. We're going for VI. We have this thing is divided by 2. Divided by 2. We're undoing. So what's the undo of divide? Good. Times. By what? By 2. By using the same thing on the top as on the bottom, we do the same trick from before with the units. 5 over 5, they're gone. 2 over 2, they're going to be gone. Okay, in the next step. But first, what you do to one side, you do to the other side. So you multiply that side by 2. The seesaw, it was twice as big, twice as heavy on this side. But now this side's twice as heavy as before. Worked out, it's even now. Well, you can't see that. This side was twice as heavy, it got like this. And then this side became twice as heavy, so balanced back out. So now it's good. Now we do some work. 2 times 4, 8. 2 divide, I know it says times, but times just put it in place. And so it's you treat it now as divide. Well, the short answer is a long answer. This is like 2 over 1. So you go multiply fractions. This 2 ends up on the outside. This 1 just times 2 is 2. So this 2 will end up on the top of the fraction. 2 divided by 2 like that. That's why they can disappear. It's kind of there's a little step in between. If you're nervous about it, send me an email. But these can divide out. And this leaves the top only, because the bottom has been removed. This means we can leave the brackets off. And we have this. Right? Any exponents now? No, no exponents. So the last thing to do is the brackets, which we left off, right? Brackets are there. So to get VI by itself, we do the opposite of plus 2.3. Subtract it away. Subtract it away. And so now you get VI is equal to 5.7. I'm going to assume meters per second, but yeah, officially it doesn't say. So 5.7 is what we get by doing this good work here. Okay, so these were, this approach was substituting the numbers in first and then solving for the variable that was needed. The other way is to rearrange the letters first. A little bit more of a workout, I think, if this is fresh for you. But really it's something you should be able to do eventually. Nice at the start of class, but as long as you can develop this skill, you'll have a successful life. So the goal is to get VI by itself still. So because there's a whole bunch of letters, let's make it clear the one that we're going for. VI is equal to what? You can even do that with the numbers, but it's just a bit more obvious then. Now this extra help could be useful. Okay, but still, because we're solving, we're going to go start at the bottom, bedmass backwards. All right, adding or subtracting? No. Any multiplying or dividing? Yes, just like last time. We have a divide by 2 here. So what are we going to do? We're going to multiply this side by 2 so that we get those 2's canceling out, dividing out officially. And because this side is now twice as heavy, got to have this side twice as heavy as well. Alright, so the 2's are in place. Why? So that this happens. This 2 is in place so it stays balanced. Okay, but we can move forward with our lives by dividing that out and writing what's left. And that's the top part only. That's VAV there. AV. So we're almost there. We want to get VI. We have VF in the way though. So because it's a positive VF, we'll subtract it away from this side, meaning this side's now lighter. This side's going up. So we have to subtract it from this side as well. And so on the left, we get this expression. 2 VAV, V average, minus VF, which is actually V final. These are going to disappear, cancel one another out, leaving VI only. Okay, well, let's get the numbers in there. Finish this up. As you can see at the top, we got 2 times, what's V average? 4 point nothing, 4. We got minus V final, which is 2.3. And squeezing it in here, it equals VI like that. So this creates an 8 minus 2.3, which actually we actually ended up in the other version, the other answer. 8 minus 2 is 6, minus another 0.3, 5.7. Any units for this one? Still no. Okay, so this solution here is using the letters first. They get the same treatment, right? But because they're letters, I think it might be a little more awkward to begin with. All right, a couple questions to go, or a few to go. One more like this, or one like this. Let's see here. Got to find the value of m for this thing. Right. Okay, so we'll do the numbers first. mv squared. Don't worry, I know you're wondering where this equation comes from. I'll show you, but later. You can see for yourself that Ek is equal to 5. Happens to be kinetic energy. You can also see that we're looking for m. So let's do that in the beginning, even if we're doing the number version. M. And then lastly, we're doing v squared. So we got to use brackets if we're going to get along when we have terms crushed together like that. No brackets, it can get potentially messy and potentially a problem. All right, so going bed mass backwards then. Bed mass from the bottom. Any adding or subtracting? No. Multiplying or dividing? Yeah. All right, we have a half here. You can think of it as top divided by the bottom. You can think of it as a top divided by 2. So what's the opposite of divide? Times. Multiplying. So I'm going to multiply this by 2 so that these will disappear. Top divided by the bottom. And that means I'm multiplying that by 2 so that so that our seesaw stays even. Gone, gone. And I know I'm still dragging this down. You could have worked that out a while ago, but just because. All right. Now we do with any Deal with the exponents here. So we get 1,000. Now this exponent I might add is for getting a bit awkward, but on the variable. There aren't any. So we just work this out. 3 squared, 9. That's 9m. And now we're back. These are multiplied, so you divide. 1,000 over 9. That's what m is going to be. Probably kilograms being the base unit, but this is what it is. Okay, you could plug it into your calculator if you like. And you would see it's about 111.1 repeating. Right, that was the numbers. Let's do the letters. Letters first. Letters first. So EK 1/2 mv squared. What are we solving for? M. All right, so I'm going to multiply by 2 times by 2. Which side? Both sides. Times by 2. So get times by 2 times all this. 1/2 mv squared. Time should be on that side in there, actually. That shows the meaning. This is the math. So these 2's can divide out, and we're left with 2ek mv squared. Solving for m. So notice, v squared is like a thing. So we can divide by v squared. We can divide by that thing. So we do that. Divide by v squared. Divide by v squared. And we get this expression here being equal to m. Sub in the numbers. We're done. What goes in for EK? 500. 500. What goes in for V? 3. Bracket, so we're not going to get along. Okay? Not in this case, but if there's minuses and stuff, like really, it's a source of error. So you have to use brackets with exponents. What do we get? Same as before, which is good because it's the same question. 1,000 over 9. Anything over 9 has all these repeats. So it's going to be like 111.11 forever. No units, but we're going to call it there. Now, what we did are a couple of very good examples. Yeah, typical of some questions that are going to be coming up in your lives. But we want to do another trick with it. And that is trying to figure out what units are. And that's what goes in this blank right here, actually. In addition to doing calculations with numbers, we can do calculations with units. And this helps, well, see if you've done a question correctly. If you're doing research, this helps figure out what new units are going to be. It's like the inventing part of science. So let's check this out. How does this work? Well, we have this formula here, which I know what it is, but you don't yet. It's in it's in week 3.5. No. Yes. 3.5 or so. So what we want to do is we want to get the units for W. Not the number answer or anything, the units. Okay, like meters and kilograms and stuff like that. Meters, kilograms, seconds, that sort of thing. So you got to go back to the first lesson, first session. The units for F. Well, F is force, described by Newton. So the unit for force is N. D is for distance. And distance, of course, in SI, metric system, distance is a measure of length, which is the meter, which has a symbol of M. So what we can say is W here, it's not equals, it's more like, I'm going to put it like that. And then in brackets, units, just to show we're not reinventing the universe, not creating a formula that is of questionable quality. Right? This topic has to do with the units. So W is equal to F times D. We have force and distance. The units for force are newtons. Units for distance are meters. As the formula shows, you multiply them together. So you multiply them together. And all you can do is just show it. So you can put a dot there. Right? And then this thing, you can have a name, this new unit, and it's called the Newton meter, or Newton meters. All right, so more on this later, week 3.5. Let's take a look at this last question. Units of A. Well, you might remember from our first session that this is acceleration, and you're actually told what the units are. Meters per second squared. Okay, well, this is one version of the units for A. There's another way of thinking about A as well, and we'll come to that week 3, just before the other formula there. So let's see what we got with this one. We have F is equal to ma, which is pretty famous, Newton's second law. Right? So we want to get the units for A. So we have to provide the units for F and M there. Units for F, as we just saw, newtons. Units for mass, kilograms. And A is what we're going for. So, as is described up here, these units, variables, they work the same as numbers. So we have kilograms times by A. We want to eliminate this, get rid of it. So we divide by kilograms, because then we have kilograms on the top as on the bottom, and on the bottom, so they'll divide out. And what you do to one side, you do to the other, so that the seesaw stays level, so that the equation stays equal. And you get now that the units for A, acceleration, are newtons over little k, g. Newtons per kilogram. All right, good people. Well, that concludes this section, this session here, where we did what? Well, we'll remind ourselves how to solve some equations, or find the value of a particular variable. Remind ourselves how to solve for a variable when it's embedded inside of an equation. Bed mass and bed mass backwards. And then lastly, we did a little little look here just to show that we can do this with units as well, which is going to be important for our later work. All right, well, thank you for stopping by. That concludes this. I'm looking forward to seeing you next time. Take care until then.